For this question, we want to graph the solution set of the following system of inequalities. And the system we have is a nonlinear system. We have x squared plus y squared is less than or equal to 49, and x plus y is greater than 5. So when we graph the solution set of a system, we need to graph the individual inequalities onto the same coordinate plane. So we'll start with the first one, x squared plus y squared is less than or equal to 49. We're going to start by graphing the boundary. And to get the boundary, we're going to replace that inequality symbol with an equal sign. That's x squared plus y squared equals 49. Then we want to decide whether we're going to include the boundary in the solution set or not include the boundary in the solution set. For this example, our inequality has an equal to and our boundary is an equal to. So that means we're going to include the boundary in our solution set. And the way we include the boundary graphically is by drawing that boundary with a solid line. The solid line indicates that that boundary is part of the solution set. Now looking at the equation of our boundary line, x squared plus y squared equals 49, I can see that that fits the pattern of a circle. We have an equation of a circle being x minus h squared plus y minus k squared equals r squared, where the ordered pair hk is the center of the circle and r is the radius of the circle. So looking at our equation compared to the general format of the circle, actually we usually call that the standard form, we can see that we have a center of 0, 0 and a radius of 7. So we're going to draw that boundary line by plotting the center of the circle. The radius is defined to be the distance between the center and the points on the circle. So I'm going to go from the center and count 6 units away to the right. I'm going to count, 7 units away to the right, 7 units down from that center, 7 units to the left from that center, and 7 units above from that center. And then we'll sketch this circle by connecting those 2 points. That gives me the points that have a distance of 7 from the center. Then we want to do the shading. To find the shading, we're going to need to choose a test point. And that test point is going to help us to determine which side of this circle will give you points that make the inequality true. So most people like to pick 0, 0 as the test point. We can choose 0, 0 as the test point even though it's the circle, because the only rule for the test point is that you're not allowed to pick points that are on the curve. So the points that are along the outside of the circle are not allowed. So I'll pick the ordered pair 0, 0, and we'll substitute that into the inequality. X squared plus y squared is less than or equal to 49. And that gives the statement 0 squared plus 0 squared is less than or equal to 49. And when we simplify, that 0 is less than or equal to 49. That is a true statement. 0 is less than or equal to 49. So my test point of 0, 0 When we substituted that test point into the inequality, we got a true statement. And what that tells me is that all of the points inside of the circle will yield a true statement when substituted into the inequality. And that means these are the solutions to the inequality. So we want to shade those solutions which are on the inside of the circle. If we had gotten a false statement from our test point, then we want to shade on the other side, which would be on the outside. So now we have a picture for our first inequality, and we'll do the same thing for the second inequality. That's x plus y is greater than 5. We'll start with the boundary. And to get our boundary, we'll replace that inequality symbol with an equal sign. That's x plus y is equal to 5. We want to decide whether to draw that boundary with a solid or dashed line, whether we're going to include that boundary in the solution set or not include it. And this time, because our inequality symbol does not have an equal to, we will not include the boundary line. So that means we're going to draw the boundary line as a dashed line to indicate that it's not included. So our boundary line is x plus y is equal to 5. We can subtract 5 on both sides to get the equation y equals negative x plus 5. This is an equation written in slope-intercept form, y equals mx plus b. So our equation has a y-intercept of 5 and a slope of negative 1. We can use that to graph the line. We'll graph the y-intercept at 5 and then use the slope to get to the next point. So we'll write negative 1 as negative 1 over 1, so that means we have a rise of negative 1 and a run of 1. So we're going to go down 1 and right 1 to get to the second point. And we're going to connect those 2 points with a dashed line to indicate that that boundary is not included. Now that we have our boundary line, we'll figure out where to shade. To figure out where to shade, we need a test point. We'll choose the ordered pair 0, 0 since it's not on the line. We're choosing 0, 0 again. And we're going to substitute that into our inequality. X plus y is greater than 5. That would lead to the statement 0 plus 0 is greater than 5. 0 is greater than 5 is a false statement. So this time the test point came out false. So that means all of the points on this side of the line will yield a false statement once we substitute it into the inequality, and that means they're not solutions. The other side of the line will give us the true statements and the solutions. We want to shade that side. So I'm going to shade that side of the line. And now we can see the solution set for the second inequality. Then we want to think about what is the solution to the overall system. Solution to the overall system will be ordered pairs that make both inequalities true. That means we want to look for where these two regions overlap each other, where they intersect each other. So I'm going to highlight here where the orange and yellow overlaps. So this region contains ordered pairs that are solutions to both inequalities, which means they're solutions to the system. And because this boundary line is dashed, this boundary line is not included in the solution set, However, this line over here, this boundary line, is included because that boundary line is solid. So this region here represents the solution to the system of inequalities. Thank you for checking out my videos. Have a great day.